slightly explain it a little bit.
Okay, no problem. Okay, so we will talk it again. Okay, the cumulative distribution. The cumulative distribution is very similar to the frequency distribution we talked about before, okay, on the first hour or 2 weeks ago. So you will find here, usually we will show the data set into different category or into different groups. For example, here you will find, okay, the the data you get, you will divide them into 10 to 14 days, 15 to 90 days, 20 to 24, 25 to 29, 13 to 34. Then you will calculate the relative frequency or the frequency. But in the cumulative distribution, that means you need to cumulative them. Okay, you need to cumulative them. So for the item of it, it will become, originally it will be 10 to 14, 15 to 19, 20 to 24. But now you have to express them by less than or equal to 14, less than or equal to 19. Okay, and when you express them, you need to cumulative them. Okay, you need to add them to get the result. For example, it will show the number of the item with the value that less or equal to the upper limit of each class. For example, here, okay, let's come back to the frequency data. You will find the frequency from 10 to 14 is 4, from 50 to 90 is 8. So if we express them by the cumulative distribution, less than 14 will be 4. Okay, less than 19, okay, there will be 12. Okay, because you know from 15 to 19 there are 8. Okay, but 10 to 14 is also less than 19. So you have to add them together to get 12. Okay? And if ask you that is less or equal to 24, then this will be how much? It will be 17. Because you know, okay, 20 to 24 is 5, but less than 24, that means 10 to 14, 15 to 19 should also be included. They are 4 plus 8 plus 5, so you will get 17. Okay, so that means we are cumulative. Okay, we are cumulative. So here you will find is 4, 12, 17. Okay, then if we use such concept, you will know it's also the same for the cumulative relative frequency distribution, because at the beginning, okay, the relative frequency from 10 to 14 is 0.20, from 15 to 90 is 0.14. Okay, so how to express then if we would like to say is a cumulative relative frequency? So 10 to 14 is 0.20, and less than 19 is, okay, is 0.60. Okay, because we cumulative them. And less than 24, okay, we need to cumulative them is 85. Okay, less than 29, we will cumulative then is 0.95. Okay, and less than 34, okay, is 1.1, 1.00. Okay, so you will find here, yes, 0.20, 0.60, 0.85, 0.90, and less 1, it would be 0.1, it would be 1. Okay, the total is 1. So the same concept for you to express the cumulative frequency distribution, okay, you need just to multiple 100 or 100 percentage. Okay, so you will get 20, 60, 85, 95, and the last will be the 100. Okay, will be the 100. So it's a cumulative distribution. And the next is stem and leaf display. Okay, we call it 茎叶图, okay, in Mandarin. So the stem and leaf display, it show the rank order, okay, rank order and shape the distribution of the data. 为什么会 why we will say it's a stem and leaf? Okay, you can image, yeah, it's a leaf you get, okay, from a tree. Okay, you will find there are stem, and there may have some other small stem on it. Okay, so that means the data they express looks like a leaf. Okay, and there are many stem on it. Okay, so they call it a stem and leaf display. Okay, so it's very similar to the histogram on its side. Okay, but it will sometimes to show it to leading the digits of each data item and are arranged to the left of a vertical line. Okay, and to the right of the vertical line, they will record the last digit for each item in rank order. Okay, so each line in the display is referred as a stem, and each digit on the stem is a leaf. Okay, so usually you will find the stem and leaf display. You will find there are stem and there are leaves. Okay, that means, for example, today I will say the unit. Okay, the unit is 0.1. Okay, or the unit is 1, then the 5 to 7, that means there will be a number that is 5.2 or 5.7. Okay, and there may be in here. Okay, that means there are data. They are 6.2, 6.2, 6.2, 6.2. Okay, 4 times for the 6.2, and 1 6.5, 1 6.6, 1 for 6.7, and triple 6.8, and double 6.9. Okay, you will find they are shown in rank order. Okay, in rank order, and each line in the display is referred as the stem, and each digit on the stem, they are a leaf. Okay, so for example, okay, a single digit is used to define each leaf, so we can define the leaf unit. Okay, the leaf unit, you can define them just like here, 110, 1.1. Okay, here. So the leaf unit, if is not shown, we will assume it's equal to 1. Okay, so the leaf unit indicate how to multiply the stem and leaf number in order to approximately the original data. Okay, approximate. Okay, it's approximately to express the original data. Okay, so for example here, if the leaf unit is 0.1, okay, so you can write down a stem. Okay, and you will find, okay, my leaf unit is 0.1, so 8.6, how to write down it? I will write down 8, 6. Okay, and the second is 11.7, so I will write down 11, 7. And then 9.4, okay, I will write down 9, 4. Okay, 9.1, okay, it's 9. I had already done. Okay, 1, okay, write down here because I need to follow the rank order. Okay, and the next one is 10.2, so it will be 10, 2, and 11, 0. Okay, 11 had already here, and 0. Okay, because I need to write down in the rank order. Okay, so 0 is less than 7, so it will be on the rank before the 7. Okay, so just like express like this. Okay, and the next is 8.8. 8 is here, and the 8, okay, is after 6. Okay, so you will find those data could be expressed in the stem and leaf display, but you have to tell your customer, your boss, okay, your audience, that the leaf unit is 0.1. Okay, so you will find, oh, that is 8.6, 8.8. Okay, they are in your data. Sometimes we can use the leaf unit if they are 10. Okay, we express them. So how to express them? For example, here, you get the data is 1806 and your leaf unit is 10. So you can think about, if 1806 divided by 10, it would be 100. 118 0.6. Okay, 0.6. But today your unit leaf unit is 10, so we will not to see uh the number, okay, less than our unit. So what we need to do is to write down 18 and it's 0. Okay, 18 and 0. Okay, 18 and 0. So here you can also to see such data, that is 1717. Okay, and today our leaf unit is 10. So you know this is unit maybe 1 and this is unit that is 10. So the last one, okay, the last number you will investigate is from this. Okay, so less than such unit, we will neglect it. So here, what we write down will be 17.1. Okay, 17.1. And the other is 1974. Okay, 1974, because today our leaf unit is 10. Okay, so you will find this unit is 1, this unit is 10. So less than the unit, the number we will neglect. Okay, so here we will write down, it will be 19.7. Okay, and the other one is 1791. Okay, because the leaf unit is 10. Okay, the first one it will be 1 and the next one is leaf unit is 10. So here we will find is 17 we have already write down, and the other on the leaf will be 9. Okay, so you can follow such a rule to finish the stem and leaf display. Okay, so if we believe the original stem and leaf display has condensed the data too much, okay, we can stretch the display, okay, vertically by using the two stems for each leading digits. Okay, for example, if today, yes, any questions? Any questions? No? Okay, I will. Eh?
It's Marian, and she said that,
Sorry, Miss.
would you
Can
like
you
to?
repeat the last previous slide? Any questions about this? Yes? The stem and leaf display, you have to remember the important thing is the leaf unit, how much you need to define it. Today, if the leaf unit is 0.1, okay, that means they will you today you will have so much numerical data. If your leaf unit is zero point 0.1, okay, that means in such condition you will express them For example, 8.6, it will be A6 because you know the leaf unit is 0.1. Okay, and 11.7, you will express then 11.7 because you know the unit is 11.7, but you write down will be 11 and 7 because you know the leaf unit is 0.1. For example, here you find there are 11 0. That means you must have a data that is 11.0, right? Here. Okay, so till here, understand, Mariam? Okay, is 10. Okay, so I will continue to talk about when it is 10. Okay, so today, if the leaf unit is 10, okay, for example here, 1717, you will know this is 7. You will know this is 10, right? So today, the leaf unit is 10. That means, okay, your unit will be calculated from here. If the unit that less than this one, okay, for example, this is 7, we will neglect it. So you can express such a result, okay, in your stem and leaf, okay, it's approximate the original data. So when you see this one, 1719, what does that mean? That means there must be a data code 17110 blah blah blah, okay, or a data that is approximately 1719 blah blah blah. So you can come back to check. Yes, in such a situation, there is a data approximately to 1910. Okay, that is 1770. Okay, 1710. That is 1770. The other approximately, okay, the original data 1719. That is 1791. Okay, for example, today I would like to express that how to express the 1806 into the stem and leaf display, okay, with the leaf unit 10. Okay, you will find 1806. Okay, in such condition, you know this is 6. This must be the unit is 10, right? So what you need to calculate is from here. Less than this one, you will neglect. So you can express them that is 18 0. Okay, 18 0. So if you find this table and you know the leaf unit is 10, you will tell me, yes, there must be a number that approximately is 1800. Okay, because my unit is 10, so I use them multiple 10. Okay, and the next, for example, is 183A. Okay, 183A. Okay, you know this must be 8. This must be 13, right? Because its unit is 10, right? So you will express them from this and neglect that the number less than the unit, okay, will be neglected. So it will be 18.3 here, 18.3. Okay, so when you finish those arrangement, you have to uh, rank them in order. Okay, in order from small to large. Okay, so this is the stem and leaf display. Marian, do you understand now? Is it okay for you? If no problem, I will continue. Okay. Okay, I will continue. So the next one, it tells us, okay, today you will find if the data set you collect or you get has a lot of uh the the number they repeat again and again. Okay, for example, here you will find, yes, maybe the unit of it is 10. Okay, for example, the unit for it is 10, and maybe you get the data that is 262, 261, 622, 623. Okay, then you will find, because the unit is 10, so what you express them into here, you will be 62, 62, 62, 62. Okay, so you must have 62, 62, 62, 62 so many times. Okay, and then you will find if there are a lot of the data here, these must be very long. For example, 5, 6, 7, 8, 8, 9, 9, 9. Okay, here a lot of it. But if you don't want to express them into a so long, so long, okay, then you can state them, okay, into the second row of it. Okay, that is the first row you express them can uh, respond to the value from 0 to 4, and the second is from 5 to 6. Okay, for example, if today you have a lot of data that is 620, 621, 622, 623, 614, 15, 661, 671. You have a lot of the data, and you know today if your leaf unit is 10. Okay, you can express them by 62, 62, 62, 62, 65, 66, 67. Okay, blah blah blah. But this makes the numerical data became too long, so you can separate them into two rows, okay, into two row or two sentence to express it. And the first one you can express from 0 to 4. Okay, 0 to 4, so 2 2 2 2. Okay, they are less than 4. And then the second, you can express the leaf value 5 to 9. Okay, 5 to 9. So that's the, yeah, if you find your stem and leaf display, they are in one sentence is too long, you can divide them into two. Okay, divide them, express them by two row on it. Okay, and then the next I would like to introduce is, if you would like to summarize the data for the two variables, you can use some tables to express it. For example, the cross tabulation. Okay, cross tabulation is a method, the cross table. Okay, the cross table tabulation is a method for you to summarize the data with two variables. For example, one variable is a categorical data, the other is a quantitative one, or both are categorical one, or both are quantitative one. You can use the cross table to express it. For example, like here, okay, they are 300 data, okay, it collects from in your textbook. Okay, talk about the meal price, okay, and the quality rating in Los Angeles. Okay, and you will find, okay, there are 300 restaurants, and the quality rating you will find is good, very good, excellent, and its meal price you will find there are different price here. So we can use the cross table, okay, to present it. That is, we can use the quality rating, okay, as a variable that is good, very good, excellent. Okay, we can also use the meal price as the variable from from 10 to 19, 20 to 29, 13 to 39, 40 to 49, okay, as the variables for category for it. And then we can to calculate, okay, if the meal price is located in 10 to in the range from 10 to 19 and its quality rating is good, you will find there are 42 restaurants, okay, and the meal price is 10 from 10 to 19 and its quality rating is very good, there are 34. Oh, what happened? Someone's microphone. Any question? And then the meal price, okay, is from 10 to 19. Okay, the quality rating is excellent. You will find there are two companies. Okay, there are two companies. So the total, okay, the total you will find in such cross table, it will tell you, okay, in different meal price and in different quality rating, there are how many restaurant there will be, okay, and then okay, how to do such table, okay, how to do such table. First, okay, first you will know if you get such table, you have to look at this part, okay, that means the quality based on the data set you get, the quality rating for good is 84. For very good is 150. For excellent, okay, is 66. So the total is 300. Okay, so total is 300. So first you can calculate, okay, how many are good, how many very good, how many excellent, okay. And then you can calculate out the relative frequency. Okay, use 84 divided by 300. Okay, you will get the relative frequency that is good. You can use 150 divided by 300 to get the relative frequency that is 0.50. And use 66 divided by 300, you will get the relative frequency is 0.22. So the total is 1. Okay, and if you multiply by 100 or 100 percentage, you will get the percent frequency on it. Okay, so you will quickly to know the information from the cross table. Okay, but you can also tell me, okay, because there are two variables. So besides the quality rating information, you can tell me, you can analyze from such table from the other angle. Okay, that is meal price. Okay, so from the meal price, you can write down, yes, there are 78 restaurants, its meal price is from 10 to 19. 118 that is from 20 to 29, 76 is from 30 to 39, 28 is from 40 to 49. Okay, and total also 300. Okay, so you can express them from the relative frequency that is 78, okay, divided by 300. You will get the relative frequency is 0.26, okay, and 118 divided by 300, you will get the relative frequency is 0.39, okay, and the 76 divided by 300, okay, its relative frequency is 0.25, okay, and 28 divided by 300, okay, and its relative frequency is 0.09. So the total is still 1. And if you multiply by 100, you will get the percent frequency again. Okay, so this is the data you can analyze from the cross table, okay, from the cross table. But there will be another interesting question that is we call is the Simpson paradox. Okay, that means sometimes you will find if we analyze the data, okay, from the cross table, we will get a conclusion. But if we dig further, okay, in the data, we will find, okay, the reversal conclusion based on the aggregate and unaggregate data. Okay, that is we call the Simpson paradox. Till here, you will a little bit confused. So I will give you an example. For example, here, there is a hotel, it's a branch on Tainan and Taipei. Okay, if we only look at such aggregate data, you will find based on the satisfaction rating, okay, Taipei seems, okay, people likes it very much, okay, and Tainan seems get bad, okay, because comparing with the percentage 14 and 88, okay, why would not compare them by the by the just the 110 and 129? That is because you will find they are in different base. Okay, so we will compare it by the same base. That the best same base for us to use is the percentage. Okay, so from such data, you will find the Tainan branch seems not perform not so well comparing with Taipei's branch. Okay, and people seems have higher preference to stay in Taipei branch or have better satisfaction in Taipei branch service. Okay, but today if we look at the unaggregate data, you will find in such results. Okay, in the Tainan, okay, in Tainan, you will find, okay, there are mountain view and city view, and people likes the mountain view very much, okay, and don't like city view, okay. And if you look at the branch in Taipei, you will also find, okay, that the mountain view, people likes it very much, but the city view, okay, people still, don't like it, okay. And from such result, you will find comparing the percentage, okay, between the mountain view, you will find, okay, that Tainan get 91 percentage, but Taipei only get 19. Okay, and if you compare the city view, okay, Tainan get 85 percentage preference, and city view in Taipei only get 80. So if you look at the unaggregate data, you will find, it seems Tainan has better performance no matter in mountain view and city view are better than the services in Taipei. But if you look at the aggregate data, the result seems not, okay, seems not the same. So it will cause an Simpson paradox here. So that means, okay, that means if we would like to use the cross table to do some analyze, sometimes we may need to set some specific context to express it. Okay, we cannot just aggregate them then to do a rough conclusion to say it is right or wrong. Okay. So sometimes we can also summarize the data for the two variables. We can use the graphical display. Usually you will find such data to get a trend line on it. Okay, for example, I believe you must saw it in some professional report to tell you, okay, maybe this is the year, okay, the age of you, okay, the age of you and the country you come from, okay, then I will draw the the dot, okay, on such figure, then each dot on behalf of you, okay, maybe, okay, for me, okay, from Taiwan, okay, comparing with you, I'm the elder, okay, so maybe this is me, okay, and maybe this is Miriam, okay, because she was very young, okay, and from the country that is on the Southern Asia, okay, from the East Southern Asia, okay, so you will find, okay, its location may be here, and its her year or her age, okay, is lower, is less than me, so its location will be a little bit lower than me, okay. So people may have different data and on such figures and data, they can be expressed by the dot, okay, and through the dot we can find the trend on it, okay. So here you will find a scatter diagram is a graphical presentation of the relationship between the two quantitative variables, okay. So you will find they are also shown in the horizontal axis and the vertical axis with two different variables. For example, the gender and the age, okay, or the working experience and the age, or the weight and the height, okay, about you or about your classmates, okay, they would be expressed by the two axes, okay, by the two axes. Then through such dot, okay, we can get a general pattern on it and tell us the relationship on it. For example, if you find those dots, okay, they are in a positive shape, positive trend, okay, that is they will increase with the same direction, okay, with the two variables, we will call it a positive relationship. If the two variables they are not changed in the same direction, for example, with the x variable is less but the variable y is higher, we will say the two variables they are negative relationship. But there are another example that is no apparent relationship, that is no matter how much changes on the x, okay, the variable y are always the same, okay, are always the same. So this scatter diagram and the trend line, okay. For example, in your textbook, you will find there are sample data that from the San Francisco electronic stores. Okay, you will find the number of the commercial those customers buy and the sales. Okay, you will find in different number of the commercials. Okay, and the sales. One is on the vertical axis, the other is on the horizontal axis, and they are expressed in such figure. And you will find there are seems has a positive relationship between the number of commercial and the sales because they seems change in the same direction. That is with the increase in the number of commercials, okay, the sales seems also increase. So we will say they may have the positive relationship, okay. So let's take a break. Okay, let's take a break and come back at 11 no at yes 11 12. Okay, 11 12. Let's take a break and please come back at 11 12.